Good afternoon, geometers. This is Ms. Backfish, and I am here to teach you to do some basic geometric constructions. And the reason I'm making this video is when I was doing this with my students, I noticed there were a lot of videos that show you how to use a traditional compass, but not many that show you how to use what's called a safety compass. It's Safe-T, that's actually the brand. And I know that that's something a lot of schools use, and it's also one that you can find pretty easily online or at Walmart or whatever. So I thought I would show you how to do it both ways, do each construction both ways using a traditional compass and also the safety compass. So we're going to start with, in this first video, a perpendicular bisector of a segment. So first off, we start out with a segment, and let me just adjust here, sorry if I make you seasick. We start out with a segment, a line segment, and we're going to create the perpendicular bisector of this line segment. Okay, so let me do it first off with the traditional compass. The first step with the traditional compass is to put the metal tip, this is kind of like the center of your circle or arc, the metal, or could it be plastic tip, but the tip that's not the writing tip, not has a pencil, on one end of the segment, and then make sure that this is open, the compass is open to where it goes more than halfway across the segment. Okay, and then you're going to draw an arc. Now, when you're using this type of compass, a couple of things about trying to get it to work well. Notice where I'm holding it. First off, hold it close to the tip that is supposed to stay in place. Not on this side where the writing surface is, not up top. Don't hold it any of those places. Hold it here. That'll help you with stability. Another thing is, you notice I was turning the paper. That can help. And then finally, notice that you can see all of the compass because I don't have it straight up and down. This would be straight up and down because the camera is above my paper. So you don't want to hold it straight up and down perpendicular to the paper. You want to hold it at an angle. Okay? And then you can draw your arc. Now, a lot of times when we do constructions, the key is that we're going to do one arc in a certain place and then we're going to do a matching arc, exactly the same size. This is why if you're using this type of compass, it's important that it's able to stay put in terms of however much you open it. It stays open that much when you go to draw the same size arc somewhere else. So I'm going to the other end of the segment, same size arc. So I have two arcs that are exactly the same size. Okay, and they are, basically each arc is every point that is the same distance away from this endpoint, and every point on this arc is the same distance away from this endpoint. So these 2 points where my two arcs cross, where they intersect, those are points that are equidistant from both endpoints. And one of the things we learned about the perpendicular bisector very early in geometry is the perpendicular bisector theorem says the perpendicular bisector is the set of all points that are equidistant from the endpoints of your segment. Okay, now usually when you're doing constructions, you don't do anything in ink. I went ahead and did this a little bit differently so you could see it. This is the perpendicular bisector. Sometimes at the end of your construction, you are asked to mark it to show what it is. Perpendicular means draw a little right angle. Bisector means draw congruence marks on either side that say this piece is the same side as this piece, or same size as this piece. Another thing that tells us is that this is the midpoint of my segment. So let me give this some letters here, and I'm going to say I have created the perpendicular bisector of segment QR. Now let me point out, if you look at videos online, sometimes instead of the arcs like you see that I have done, sometimes you'll see something that looks like this instead, where it's just two little pieces of arc that are intersecting on either side. Okay, that is done exactly the same way. If it looks like this, don't look at mine and go, oh, she did it totally differently. It's really just that they didn't continue it from here to here. They did this part of the arc and then lifted the pencil and then did this part. Did this part of the arc, lifted the pencil, and did this part. I prefer to do the arc, the whole arc, and here's why. because sometimes these guys wiggle. Sometimes it doesn't stay open exactly as far as you've opened it, which is the goal. You want one that's tight enough that it stays put when you open it a certain distance. So one of the things we do when we're using these is we try to be careful not to make it wiggle. And to me, every time I pick up my pencil and put it back down again, I've run the risk of changing just how far open it is. I run the risk of bumping it just a little bit, nudging it open a little further or closed a little bit. So I would rather keep my pencil on the paper the whole way, draw the whole arc, and then over here do the same thing. So don't think it's a big deal if it's this way. In other pictures that you see, it's the same thing. And if you prefer to do it this way, that's absolutely fine. You will still, at the end, take the 2 points of intersection and connect them, and that will be your perpendicular bisector. Okay, so let's compare traditional compass to safety compass. Okay, first off, traditional compass has the non-writing tip it pivots on. It's very often metal, sometimes it's plastic. That's the one you plant and then you rotate around that point. For this type of compass, that point is the middle of the white circle. It's that little point in the middle of the white circle. That's the same as this. So I'm going to plant this, hold the white circle down, and then it spins freely. Okay? Now another thing is, at the beginning of this particular construction, we said we're going to open the compass. I put my tip here and I said I'm going to open it so that it's more than halfway across. Let me point out, if I had not done that, if I had not opened it wide enough that it was more than halfway across, what would happen is I would have a couple of arcs that don't meet. We want them to meet twice, so that's why it had to be more than halfway across. Okay, so what do we do here when we're told to open it a certain distance? Basically, that's about choosing a point. So let's go ahead and do the perpendicular bisector of this segment using our safety compass. I'm going to put my tip over one endpoint of the segment. That's like my tip of the compass. It's the center. And then instead of saying open at a certain distance, basically you are choosing one of these dots to put your pencil in. You're choosing a point to put your pencil in that is more than halfway across. Now the next thing that can be a challenge with this, if I'm using a traditional compass and I want it to do two arcs that are the same size, I just keep it open the same distance and I go from one place to another with the arc the same distance, the two sides the same distance apart. Here, if you want to do two arcs the same distance, which we very often do, that means remembering exactly which hole you put your pencil into. And I'm telling you, that's harder than you think at first. Okay, so I end up doing with these, this is to me the only drawback of these, I end up doing a lot of double checking. Wait a minute, which hole did I use again? And I go back and I check the last arc I drew. So if I want to draw an arc that has a radius that is more than half the length of the segment, I'm going to use this point right here. I like to choose dots that have some sort of identifying mark beside them. So I'm going to use that long, the dot right by the long mark here above the 3.14. Okay, and I'm going to do that arc. And then I'm going to move the pivot point, which is like the compass tip, to the other end of the segment. And I have to use that same exact hole. I have to be able to go back to that hole. It can be even more challenging when it's upside down because that was on the top on the other side. And do that same size arc from over here. And then again, I will connect the 2 points of intersection. And that's my perpendicular bisector. It's perpendicular to the segment and it cuts it into two congruent pieces. The perpendicular bisector of AB. Now, one thing I want to point out to you is that compass constructions, geometric constructions. Talking about geometric constructions, there are always just two tools involved: a compass and a straight edge. And your straight edge does not have to be a ruler or a protractor or anything that has markings, because the straight edge really is just anything that would draw a straight line. Like I could use the edge of my student planner That could be my straight edge. All right, so a compass and something to help you draw a straight line. There's no measuring involved. You will never measure any degrees, any inches, any centimeters, anything like that when you're doing constructions. Okay, so we just need something to draw the arcs, that's the compass, and something to connect points by a straight line. That's the beauty of this one, is it's both in one. You notice that when I went to connect these, I already just used the edge here. So this does the arcs and it's the straight edge as well. So that's a nice thing about the safety compass. Okay, I want to show you one more basic construction, and that's the construction of the angle bisector. All right, let's do it with a traditional compass first. The first step is I put my compass tip on the vertex of the angle, and I open it any distance I want as long as it's not beyond the edges of where I've drawn my angle. Because what has to happen here is I have to draw an arc of any size that crosses both sides of the angle. It doesn't matter what size, it just has to cross both sides of the angle. Now the reason we did that is because that gives us 2 points. Here's one point, let's call that A, and another point, we'll call it B. What we know about those 2 points is that they are equidistant from the vertex, which I'll call V. The distance from V to A is the same as V to B. So now what I'm going to do is I'm going to draw 2 more arcs, one with the point on A and one with the point on B. These next 2 arcs have to be matching in size, and in terms of where, they just have to be somewhere out here in the interior of the angle. I usually like to draw them somewhere around here. The goal here is to make 2 arcs the same size and put them someplace where they will cross. Remember, to make the arcs the same size, you got to make sure your compass does not change when it switches from going over here to over here or vice versa. So I have accomplished my goal, which is the 2 arcs crossed. If your 2 arcs didn't cross, try doing a different size arc or try drawing it in a different place. But make sure that they're the same size from each point, that whatever you do from over here matches what you do from over here. And the last step is I take that point of intersection and I connect it back to the vertex of the angle, and that's my angle bisector. And there it is. That is the angle bisector. And how do we mark it? Not usually by writing the word angle bisector. We mark it by showing congruent symbols on either side, congruent little arcs. So I have created the angle bisector of angle AVB. Let's do those exact same steps, but this time with the safety compass. A little bit bigger angle. Remember the first step, and I'm going to put the center here of my safety compass, I'm going to put it over the vertex of the angle so that I can see it through that middle hole right there. I'm going to draw an arc. I'm going to pick any point I want to, as long as my arc will cross both sides of the angle. So I'm going to pick a point I can remember. I'm going to pick this point that has an arrow pointing to it right up here. Although it really doesn't matter. I'm only doing 1 arc this size. Okay, now that gave me 2 points. 1 point on one side and another point on the other side. And again, we'll go ahead and call this V for my vertex. So now I'm going to draw 2 more arcs, one with the center of my compass on A and one with the center of my compass on B, and they have to be the same size and they will meet somewhere out here. So again, in terms of making them the same size, it helps if I try to pick a hole that I'll be able to remember which hole I used. I'm going to use this one here that has an arrow and has a 3 right next to it, 3 inches and an arrow. Okay, and I have to remember that's the point I used, and come over here, put B right up underneath that hole, and use that same point. My pencil has to go back in the same hole that it was in. And now I will take this point of intersection and connect it to V, and that's my angle bisector. So this is the angle bisector of angle AVB, which means this angle over here is the same size as this angle over here. All right. Last thing I want to show you on this video was the perpendicular bisector and the angle bisector. Sometimes you are asked to do those things of triangles. So what I want to point out to you is if you are asked to do the perpendicular bisector on a triangle, usually what you're going to do is you're going to do the perpendicular bisector of each of the three sides. So the way that would look, and I'm just going to go through this real quick, but you do the whole process for perpendicular bisector, basically ignoring every other side other than the one you're looking at right now. So I just do it for this segment. And then I go to a different segment and I ignore the rest of the triangle. And so now I'm just going to do it for this segment. So let's use the safety compass this time. It looks a little messy. What happens is you've got it going on 3 times. This is going to be a little messy. You've got stuff overlapping. And then finally, we haven't done it to this side. So you just have to look at it very individually, one side of the triangle at a time, and do it for each side of the triangle. And I did this really fast, but if you do it carefully and correctly, what you'll notice is all 3 of these perpendicular bisectors of the sides will meet at a single point. And that's generally when you are asked to do this, is when you're exploring the properties of that point. It has a special name. It's called a triangle center. These lines are called concurrent because they all meet at one point. And that particular point is called the circumcenter. You could do the same thing with the angle bisectors. Just look at one angle at a time. So if I'm picking one angle at a time, that's like, let's say it's this one. It's like I don't think of it as a triangle. I just think of it as an angle. So I'm going to draw an arc that crosses both sides of my angle. And then 2 new arcs from those points. And I connect that intersection back to the vertex. And I keep doing that one angle at a time. So like I could do it over here. Draw an arc that crosses both sides. And move to this point. And draw an arc. And move to this point. And draw the same size arc I just drew. So I have to use the same hole. And then here's the angle bisector for this particular angle of my triangle. And so on, okay? So if you're asked to do it for a triangle, you're basically just doing it 3 times for the entire triangle to do all the perpendicular bisectors or all the angle bisectors. I hope this has helped. I will show you some more in another video, and I'll see you later.